Hi guys, this is Mrs. Cornett, and this video is all about finding the outliers of a set of data. Outliers are those extreme data points that are outside of the general expected boundary of a data. What you should already be familiar with is what is on the screen. You should know what a box and whisker plot is. If not, you need to watch a video called Box and Whisker Plot, or it may be called the 5-number summary, but you really need to be familiar with that concept first before learning about how to identify if you have outliers in your data. Okay, so on this screen, I have that an outlier is any number outside of the lower or upper boundaries. Like I just said, these would be considered the extreme data points. The concept of an outlier is very much like the unusual values when we were calculating the MAD in an earlier class. It's the same idea. It's the unexpected value in a set of data. And so there's an upper boundary and a lower boundary, and the formulas are right here on the page. To identify the lower boundary, you will work the subtraction problem, the value of quartile 1, which is also the median of the lower half, minus 1.5 times the IQR, which, remember, the IQR is the quartile 3 minus quartile 1 value. To find the upper boundary, you're going to work this addition problem. You're going to start at quartile 3 and add 1.5 times the IQR. Now these will just give you the boundaries. So any number outside of the boundaries, those are your outlier values. So any number smaller than the lower boundary or greater than the upper boundary. So let me show you an example of how these formulas work. Okay, on the screen we now have two sets of data. Let's do data set A. Before we start, we need to make sure that these values are in numerical order. And I also want to point out that you should not just eyeball your data and just make a wild guess that you think. For example, 120 is an outlier. You really do need to identify the lower and upper boundaries first, and then you can make your choice on if you have outliers or not. Okay, so where do we start? The first thing that I want you to do, and it just appeared in red, is to find the 25th and the 75th percentile first. Now, there is a video all about finding percentiles or finding the 5-number summary. So if you're not familiar with that, please go back and watch that video. And so you should know that the 25th percentile is the median of the lower half. 75th percentile is the median of the upper half. But before we can determine that, we need to know the median of the entire data. This first one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. And so the median will fall right here in between 42 and 52. We actually don't even need to calculate what that median would be. We just need to know where it's going to fall. Do you see that it split the data into two parts? We now have 5 numbers less than the median, and we have 5 numbers greater than the median. Those are called the lower half and the upper half. Next, we're going to identify the 25th percentile, which I just said it's the median of the lower half. It's also called quartile 1. And we can do this by just looking at these 5 numbers and identifying that 10 is the median when those values are in numerical order. So we'll call that quartile 1. We'll do the same thing with the upper half, and you can see that 78 is the median of those 5 numbers, and that will be called quartile 3. Now that we have quartile 1 and quartile 3, now we need to find the IQR. The IQR is called the interquartile range. It is the distance of how long the box is in a box and whisker plot. To find the IQR, it's a simple subtraction problem. It's the value of quartile 3 minus the value of quartile 1. So for question A, we'll take 78 and subtract 10, and that gives us an IQR of 68. Next, let's identify the LB, the lower boundary. Here's the formula. It says take quartile 1, which we said was 10, subtract 1.5 times the interquartile range, which is 68. Now, some of your calculators, you are able to type this in just as it's given and it works the order of operations for you. But if not, you need to do this multiplication first, and then we can work the subtraction problem. 1.5 times 68 is the value 102. And so to find the lower boundary, we'll do 10 minus 102. So the lower boundary is negative 92. Now the UB, which is the upper boundary, notice that it does not start with quartile 1. It now is starting from quartile 3, the 75th percentile. So this is 78 plus 1.5 times the IQR, which is 68. From the lower boundary, we already know that 1.5 times 68 is 102. So we can steal that answer from the previous problem. And now we're going to add 78 to that value. 78 plus 102 is 180. So we have a lower boundary of negative 92, an upper boundary of 180, and this is all for the data set in part A. To find an outlier, you first look at the lower boundary. Are any values less than negative 92? No. The smallest it is negative 6. So we're good on the lower side. The upper side, are there any values that are greater than 180? And we say no. The greatest is 120. And so for the first question, are there any outliers in the data set A? The answer is no. Okay, we're going to run through that same process again, except now we have a different set of data in B. We have the numbers 1, 65, 75, 90, 120, 160, and 350. Those numbers are in numerical order, so we can go ahead and start marking our median and then identify the 25th percentile and the 75th percentile. So because there are 7 data points, 90 is going to be our median. 90, because it's an actual value in the set of data, it's not going to be included in the lower half or the upper half. And so to identify the median of the lower half, it's going to be 65, so we'll call that Q1, and the median of the upper half is Q3. Once you have identified those 3 numbers, you need to find the interquartile range, which I have over here on the far right side of the screen. The IQR is quartile 3 minus quartile 1. In this example, 160 minus 65 is 95. Okay, so now we are ready to identify the lower boundary and the upper boundary. For the LB, lower boundary, we are going to start at quartile 1, which is 65, and subtract 1.5 times the IQR, which in this example, 95. 1.5 times 95 is 142.5. So we'll take that quartile 1 of 65 and subtract 142.5, and that gives us an LB of negative 77.5. Next, let's find the upper boundary. This time we'll start at quartile 3, which is 160, and add the 1.5 times 95, which is our IQR. From the previous problem, we already know that when you multiply 1.5 times 95, it's 142.5. So now we'll just add that value to quartile 3, and that gives us an upper boundary of 302.5. Okay, so to review, we have a lower boundary of negative 77.5, and an upper boundary we just found was 302.5. Now we're going to go back and look at our data. Does any data value smaller than negative 77.5? That would be no, so we're okay on that side. On the upper side, the upper boundary is 302.5. Are there data points outside of that, or a better way to say it is greater than 302.5? And yes, there is. And so in data set B, 350 would be considered an outlier because it is greater than the upper boundary. Okay, so let's try another example. This time we're going to go off of the data from a dot plot. Now, if you feel comfortable, there's 12 dots. If you want to list out all 12 of those values, you can. If that helps you visualize it better, on this video, I am going to just use the dots on the dot plot to find the information that I need. So the question is, are there any outliers in this data? I have over here in yellow our little cheat sheet of our little formulas that we're going to use. And so the first thing I need to do is to split the data in half so that I can identify the lower half from the upper half. Like I said, there was 12. Let me double count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so that's going to split into 2 halves, 6 for the lower half and 6 for the upper half. So 1, 2, 3, 4, 5, 6 right here. That is where the data is going to cut in half. That gives us a median of 45.5, but that information is actually not necessary. The most important thing is now that we've identified an upper half and a lower half. So this is the lower half because these 6 values are smaller than the median, and this is the upper half. Okay, next I need to identify quartile 1 and quartile 3. Remember, those are both the median of their specific half. So quartile 1 is the median of the lower half. And do you see we have 1, 2, 3, 4, 5, and 6. And if we were to find the middle, and if we found the median, do you see that it would be right here in between values 3 and 4? Well, what is value 3? Value 3 is 44, and value 4, we can safely assume that it's 45. And when a median falls in between 2 data points, we're just going to average those together, and that gives us a quartile 1 of 44.5. Okay, we're going to do the same thing, except we're going to work with this upper half of the data, and I can count it out the same way. Okay, the median is actually going to fall in between the 3 and the 4 again, which makes sense. So it's going to fall right here. And we can safely assume that the data point 3 is 47 and the data point 4 is 49. That will be 47 plus 49. If we took the average of those two numbers, that gives us a quartile 3 of 48. Okay, so that's the information that we need to know to start the process of identifying outliers. We need to know the quartile 1 with the quartile 3. Okay, the next piece of information is that we have to find the IQR, which is quartile 3 minus quartile 1, which in this specific question, it's 48 minus 44.5, which is 4.5. So I'm going to write that piece of information over here, and then I can erase the screen to make more room. Okay, first, let's identify the lower boundary. We are going to take the quartile 1, which is 44.5, and we're going to subtract 1.5 times the IQR. So that is 1.5 times 4.5. Orders of operations says you need to multiply first. 1.5 times 4.5. This value is 6.75. So now we'll say 44.5 minus 6.75, and that gives a lower boundary of 37.75. Okay, we'll do a similar process to find the upper boundary, except we'll start with quartile 3, which is 48, and instead of subtracting 1.5 times the IQR, we will add 1.5 times the IQR. We already know that 1.5 times the IQR for this problem is 6.75. So I'm just going to steal that from when we did the work with the lower boundary. And now I'm going to bring down the 48 and add 48 plus 6.75 to get an upper boundary of 54.75. Okay, so now that we have our lower boundary and our upper boundary, we can actually mark these up on our dot plot, and you may be able to visualize the concept of outlier better. Our lower boundary is somewhere right, let's see, if that's 38, it'd be somewhere right here for a lower boundary. Our upper boundary, 54.75, so almost 55, which would be somewhere here for our upper boundary. And so all of that work to answer one question, are there outliers in this data? And that would be yes. There are actually two outliers. This lower outlier looks like it would be a 31, and the upper data point would be a 69. So the answer is yes. Okay, guys, that is all I'm going to say on this video about identifying the upper and lower boundaries and then using those values to determine if they're outliers or not. Please let me know if you have questions regarding this video or homework problems. I would love to give you some help. All right, I will see you later in class.